think we have started the recording. Siddharth, can you just make sure I'm the co-host as well so I can end the recording as well? Perfect. Cool. Cool. Then let's get started. I'll bring up my screen. Let me know when you can see my R screen. Yeah, I guess something is loading in my R, so it might take me maybe a minute or two. But yeah, in the meanwhile, we can have a look at your doubts first, and then we can start with the what I've planned for today. Okay.
All right.
Yeah. So, what are the key doubts that you had? Tell me that first.
Wait, let me open my notes.
Yeah.
So I think what I texted you a few hours ago about the error, but then instead of each parameter, we want to find the confidence interval for a model. Let's say like for Y.
Mm-hmm.
And then the second is basically all the video 6 regarding the part, and then
let's go through it one by one. Yeah. For example, we have created say an X, right? This is the value of my X. This is my value of my Y. Let's create a model out of it, right? A sweet simple model. Y squiggle X. I've got a model, right? Now, if you got to as you said, right, you can use confident to basically get what? Tell me, to get a confidence interval of these coefficients, right? These ones, right? Yes or no?
That's the parameter, right? The coefficient, basically.
Exactly, the coefficient. So a confidence of M1, 1, they would give me the confidence interval of this, and this will give me the confidence interval of alpha, right? Yeah.
For now, beta, right?
For beta, exactly. This for 1, 1 gave me for alpha. This gave me for beta, right?
Yeah.
Yep. Now, if I need it for y, I'll use the predict function. I'll not use the confident function, right?
Yeah.
Say I need it for y, predict M1. First, I also need to declare a new data frame where my new x value is stored, right? Right. So say my x new value is say 30, right? And then all I need to do is NDT. This is giving me just the estimate. Correct?
Yeah.
Yeah. Now, if you remember, there was one more argument here, right? There was one more argument that helped us to justify whether we want an interval or not, right? The interval argument. If I specify this as confidence, what will happen is I'll get a confidence interval as well, right? So what I get now is a confidence interval for y. We usually won't use this confident function for getting the confidence interval of y, but we can in one case. In what case? Let's talk about that. We know that y equals alpha plus beta x, right?
Yep.
Now, when x equals 0, what is y equals? When x equals 0, y equals alpha, right?
Yep, correct.
Yeah. So finding the confidence interval of y is the same as finding the confidence interval of alpha. Yeah.
I see. But when x is not equal to 0, we cannot find this, right?
You can't use confident to find the confidence interval of y. Okay.
Yep.
Got it? So that was the first question. The next one was that because the last video of regression was okay. So when we get to regression, I'll make sure I cover all of those parts as well. Okay.
Yeah, I think we can jump to the F-test first. Then after that, we can discuss for the video 6.
Sure. Cool. Let's look at F-test. So what is your doubt here?
So basically, I want to check, right? So what if we have a multiple linear regression that we want to test whether the beta 1, beta 2, and beta 3 is equal? That's number 1. Number 2 is whether beta 1 is equal to beta 2 is equal to beta 3. It's equal to some number,
right?
You know,
right. I got a point. See,
all right.
The F-test is only used for just one H0. You can't have these many H0. Your F-test has an H0 of beta 1.
Beta 2, this is what I mean.
Beta 3 equal beta n equals 0.
Yeah.
So this 0 is fixed. You won't have equals 0.3 ever in your F-test.
So sorry. Can we just like beta 1 equal to beta 2 equal to beta 3, like without 0?
No, you can't have that in an F-test. In an F-test, you'll always have equals to 0 as well.
I see.
Okay.
Because
your
because
F test,
I opened my lecture note right from university. Then I think there's one sample that to test whether the mean 1 equal to mean 2 equal to mean 3 in the F test.
yeah. So that's a different test that we'll get to. So that's part
Okay,
we'll cover. Yeah.
okay,
But
okay.
in an F test that you get when you perform the ANOVA, right? When you use the
Mhm.
ANOVA function, you always have the H naught is equals to this.
I see, I see.
Okay.
Understand. Yep.
Right. And your H1 is equals to not equal to 0. That's all. Okay.
Oh, okay,
That
okay.
or at least one of the betas,
It's not equal to 0.
exactly is not equal to 0. That is your H1.
All right.
Okay.
Yep.
Got it. So that is your H0 and H1 for these two cases. Now, yep. Now coming to, is this clear now? All good?
Yeah, it's clear.
Right.
I think you just discussed the second and third.
Second and third. So for F test, you won't have H0 that's ever that. This is the only possible H0 and H1 that you have for the F test that is performed inbuilt by the ANOVA function in R.
Oh, okay. So in practical, it's not possible to have like just because if in T test, right, we can have like beta 1 equal to 0.2, 0.3, right?
Yeah, in reality, you'll have those values. But just
Mhm.
think about it. When you are thinking of whether a linear regression exists between your y and x, right? Your linear relation does not exist when the beta corresponding to that x is equals to 0, right?
So sorry, cannot get it.
So, for example, let's just consider a single univariate analysis, right? Or y equals alpha plus beta x. Okay. Now, is it fair to say that this y and x don't have a linear relationship at all when b equals 0? Correct? Yeah, because then you can't explain the value of y using the values of x, right? It's just an intercept term that's helping you, or there's some other term, the error terms are taking up all, right? Your x is not very useful, right? That's the point, right? So it is of particular important significance for us to test whether the betas are equal to 0 or not, because that tells us, this basically tells us, this H0 tells us there is no linear relationship. Okay. And
I understand.
Yeah. So that is the main concern that we have here. We are not testing whether like beta has a particular value or not. What we are particularly interested in testing when it comes to H0 and H1 in an F test is whether there is a linear relationship or not. And H0 tells that there is no linear relationship, and H1 tells that there is a linear relationship.
And I can understand, but just wonder, right? Then what's the purpose of us having a test in teach statistic that beta is not equal to 0, like beta is equal to 0.2?
It just tells us that there is at least one independent variable, one of the x1s, one of the xi's that has a linear relationship by. So the entire model is not junk, right? You can retain at least one of the betas.
I cannot retain one of the beta.
You can, if you are rejecting this test and you are saying at least one of the betas is not equal to 0, right? There is at least one of the explanatory variables that you can retain in the model.
Okay.
Right? Because one of the betas is not equal to 0. That means there is a linear relationship between that independent variable, that explanatory variable, and a response variable. Yes.
If beta is not equal to 0, meaning that there's a linear relationship between dependent variable and independent variable, isn't it?
Exactly.
Oh, okay. But I mean, I still cannot get it. Like when we test, like just now, what I say is either equal to 0.2 or it's not equal to 0.2. You know, instead of equal to 0, we want to test.
So you'll have to do separately for every parameter. Okay.
Yeah. You know, I mean, like in practical, what is that for?
Oh, in practical, then you have this you get that H0, right? But you'll get it individually for each one. So beta equals 0.2, and then H1 you'll have beta 1, say not equal to 0.2,
Yeah,
right?
yeah.
This test we are talking about.
Yes, but
right?
in practical, what is this for? Because
This
if
is
equal to 0,
okay.
we want to test whether it's linear or
Yeah,
not linear,
correct.
right?
And practically, what is this for? So you are basically saying when this is the case, your linear regression is of this form, right? Y equals alpha plus 0.2 into x, correct? Can you say that when you increase x by 1 unit, your y increases by 0.2 units?
Correct.
So you've got a del y del x. That, for example, if you're talking about, say, GDP and income, right? If income increases by this, GDP increases by this, right? Or if say mortality rates increase by this, your payments for your a portfolio increase by this much amount, right? So it helps you to get the incremental change in y for every unit change in x.
All right. Get it.
Right.
Yeah, get it. So it's back to my question. Right? So it's not possible that we have like beta 1 equal to beta 2 equal to 0.2, right?
Exactly. You don't have a test like that.
Okay. So F test is only, it's about whether it's linear or it's not linear, right?
Exactly. Where you're testing equal 0 or not equal to.
So
Or at least one of them is not equal to 0.
What makes F test and T test different is in F test we can test multiple elements in one calculation. Meanwhile, in T test we have to do multiple times, right?
Right. But in F test, you can only test equality with equals to 0. In a T test, you can test equality with any number.
I see.
Right?
Yeah. So meaning the third point that I asked you also is not possible, isn't it?
Yeah, that's not possible as well. Correct.
Okay. But then beside the coefficient, right? Can we test like for mean or for other things, like, because like when I open my notes, there's a term like MSA, MSW, like among the groups, within the groups.
Yeah. You can test that. So that's something that so these videos help you get through the basic linear regression. When we get to the advanced part of it, we'll cover all of those.
Okay, all right.
Then
I think now we can continue to the plot for the multiple linear regression, and also I saw in the video like you remove you have the x1, x2, and x3, and then you remove one by one.
Yeah. Good. So what we've got I guess a pretty decent understanding of linear models, but that is not the entire portion in the syllabus, right? There's much more to it, like we have for data visualization and plots, right? So today what we'll do is chapter 2, we have plots, right? What we have done is we have covered basic plotting functions in R, right? Say plot function, hist function, bar plot function. Now all of that can be done with a single function in R. Okay, and that is the GGPlot function. Okay, so today we'll talk about devote some time in talking about this GGPlot function. Okay.
All right.
Yeah. Let's take this R to maybe completely understand what this GG. Maybe not completely understand. Maybe today and tomorrow as well. I will schedule a class, and over these 2 classes, we'll talk about that. Okay.
All right.
So, are you aware of the concept of packages?
Yep.
Yeah. So packages are basically a collection of functions, right? So there's this package called GGPlot2. Can you see whether it's installed on your system?
Let me check.
If it's not installed, just install it quickly.
Yeah, it's installed.
Just then attach it. You have to.
I think the checklist is already installed.
Yeah. It's installed, and then you just pick it as well, so you can use its functions. Now, the key functions that we'll be using here, okay, will be the GGPlot function itself and the geom functions. Okay, so what are the 2 names of the functions? First, you have something called the GGPlot function, okay, and then you have something called the geom function. And the interesting thing about GGPlot is that you will be using most often these functions together. Okay, that in the same line, you will see both of these get functions will be used together. Okay, right?
Okay.
So how do we proceed with it? Like what is the function of these 2 things that we are going to talk about, right? So as we did every time, whenever we are learning about a new function, it's a good practice to go and look at the help text, right? So let's look at the help text, right? What do we have in the help text here? Now you can see that there are two key environments, two key arguments here. Okay, the first one is your data argument, and the next one is your mapping. Okay, the data argument basically feeds a data frame to GGPlot. We know what a data frame is. It is a particular data type in R, right? So we'll have some sort of a data frame that's ready with us that we want to plot in R, right? For example, we know how to create a data frame, right? Let's create a DF1, say that has some sort of values, right? Say to what? X equals, let's take random numbers for the timing, right? That don't have a like pattern. So again, you will learn about how to generate these random numbers. So don't worry about this. This is one of the ways that we can generate random numbers. Okay. So don't worry about what the code here is, but I'll just show you what the outcome of that is, so you don't not in a black box as well. Just give me one moment. Okay, so I've executed this. So if you look at DF1, it has basically two columns. Okay, now it has two variables, X and Y, right? Let's do one thing just to keep it a bit different. Let's name it A and B, right? Usually our variable names won't be X and Y, right? For X and Y axis, usually there will be something different. So I'm just named an A and B. And they're just random numbers. The first column has random numbers between 1 and 100. The next one has between 400 and 800. Okay, what we'll try to do here is try to create a plot with the ggplot function. Okay, and we'll see how exactly is it done. Yeah, so as we were discussing, the ggplot function will have the first argument is what? The name of the data frame. Yes. So df1 is where I have the data. Okay, the next argument is where the mapping function goes, right? The mapping argument, and this is a very key argument when it comes to ggplots. This AES, okay, this AES that you see here is called aesthetics. Okay, basically all the elements, okay, that will help you connect the data as well as the graph will be presented using aesthetics. Yeah, this aesthetics argument will help you figure out all your mappings between the data and the variables. Okay, between the graph and the variables. Okay, if there is anything in the graph that you want differently for different variables, you will have to indicate via this aesthetics argument. Okay, so far so good, right? So for example,
just go to example.
Yeah, let's have a look at an example. I think example will make it clear. For example, I need to somehow tell R that this A is my X variable and B is my Y variable. Yes or no? That is one of the key pieces of information. So what do I need to write? X equals A, comma, Y equals B. To say that the column A in my DF1 is my X variable, and the column B in my data frame is my Y variable. Okay. Now what do you see here? You just see an empty graph, right? When I plot this out, I don't see any points. Correct? I don't see any graph of sorts. I just see an x-axis and a y-axis, right? That is where the next thing comes in. What? The geom function, right? This geom function basically tells R what is the kind of graph do I want. Okay, and again, R has a lot of inbuilt things here that we can use, but we'll limit ourselves to what we need to understand to get very comfortable with the ggplot function. Okay, for example, this first one is what? Geom point. Now, if I execute this together, what do you see? All my points has come as, all my x and y coordinates has come as black circles. Got it? So how did it happen? Because I gave another function here along with ggplot, which is the geom function. The geom underscore something tells R what is the kind of graph do I want to plot. Got it?
Also, we have to plus. Is this required?
Sorry, we have to what?
The plus sign. Is that required?
Yeah, that's required. Okay. Or else it won't execute. Okay.
Okay. Just wonder, right? I mean, this function can be found in normal plot, right?
No, this won't be found, not a normal plot. So that is why I wanted to make you comfortable with plot hist first, because at the end of the day, if you think about this, you can do simply a plot of x comma y here, right?
Yeah, but I think if in normal plot we also can generate this kind of plot, isn't it?
You can, but there will be many more functionalities that GGPlot will give you right now. So we'll learn about all of these step by step. Okay.
Okay.
Now, what are the other functionalities? For example, if you want a color for everything, right? So I can put, say, color equals blue. Now, when you look at it, all your points turn blue. Okay. Although it was possible in your graph as like in your plot function as well. What else? Now, one of the requirements here was that let's get everything is blue, right? What if I wanted some points at red and some points as blue? And that was based on another data attribute. Say there was a data attribute called, say, section. Okay. And that section was, again, you don't need to worry about what this thing is here. I'm just making sure that I have a column here. Just give me one moment. A comma B comma C. One moment. 2. Okay. Now, if you look at TF1, just look at the output of TF1. What I've done, I've assigned every row to a particular section. Okay. Can you see that? Yep. So what I've done is I've introduced one more variable in this. I don't want it on my plot, but what I want is I want A to be in a different color. I want B to be a different color. I want C to be in a different color. That's what I want.
All right.
Did you get my point?
Yeah.
Yeah. That I want A to be in a different color, B to be in a different color, C to be in a different color. Understood? Yeah. How can I do that? Now, what did I say? Any mappings between the graph and the variables will have to flow through where? This aesthetics argument. Right? Now, color is something that I want to be different for different based on a values of a particular variable. Yes. And like we discussed, any information that is flowing to the graph from your variables will have to come from this aesthetics argument. Correct? So I will not put the color thing here. What will I do? I'll place color thing somewhere here. Yes or no?
Yes.
Yeah. What can I do? I'll do one thing. I'll say try something like color here, right, is equals to, say, SEC. Yeah. But what will you see? This has not flown through, right? Why? Any ideas? Because there is no color called A, there is no color called B, there is no color called C. Yeah? Yeah. So what can I do? Instead of this, I'll give colors here, right? So for example, R understands 0, 1, and 2 as colors. Okay. So I'll just put SEC instead of A, B, C, I'll put 0, 1, 2. And then let's see what happens. Okay.
Okay.
Just give me a second. What has happened here? Just a moment. Some problem there. Just give me a moment. This is weird. Just give me 1 second, yeah. Factor of SEC. This should work then. If this even doesn't work, that's a problem. Yeah, let's have a look here. Why is this not working? So I'll tell you what I expected here to happen. Okay. What I expected here to happen basically was that A, like 0, 1, and 2, right? There are 3 different colors now. All of them will be colored differently. Can you tell me why that has not happened? Any guesses?
Because we do not specify like what color in 0, what color in 1, what color in 2.
No, like, R is smart enough to understand that because R has some color stored for every number. The problem was that we haven't given it within the AES argument. So again, any mapping between the data and graph flows through within the AES argument. So it should have been within the AES argument, and I had given it after I close the bracket. Okay, got it? It's a concept clear? So it should have been within the brackets of AES.
Just now, isn't it in the bracket of AES?
Now I've put it in AES. So when I plot it now, then I expect it to go through. So it's still plotting through. I guess I didn't close a bracket somewhere. That's why it's throwing an error. A moment.
I think your GGPlot, yeah.
Yeah. Now have a look. Can you see now?
Yeah.
Yeah. So what has happened? It has drawn a scale. It has given 0 the darkest color, 2 the lightest color, and 1 a color between them. Right? So if you would have had 1.5 as well, it would have given some color that's of this shade. Now you can differentiate between different sections. Yes or no?
Yeah.
Correct. Or if I didn't want say all the scales, right? What I could have done was I could have simply written factor of sec. Okay. Let's look at what happens with factor of sec. It takes only 3 levels: 0, 1, and 2.
All right.
Okay. And it does not draw a scale of all colors in a shaded region between 0, 1, and 2. Okay. Does this make sense? So far, so good. Tell me. So what we have learned till now? Good.
Yeah, this is makes sense. Just wonder if we can change the color. I mean, like instead of orange in 0, then maybe
you can change the color. You can change the color. So for changing colors, what you'll have to do is you'll have to give it a color shade as well, right? So you'll have to give it for what you want, what color, right? You'll have to give that information to us. But usually when it gets to GGplots, we don't go through that like pain, right? We let the color be something that R decides on its own. Okay, usually that's the case. I'll tell you what's the reason. The reason being that R automatically adjusts its color scheme to be sensible enough, right? Now, if you want that to be the case, what you'll have to do, you'll have to like put in an if condition here and say if sec equals this, then that. If sec equals that, then this. For example, we can put in an if else condition here, right? And say if sec equals say 0, then give me blue, right? If else, I'll have to put another if else, right? Because there is, so I'm creating a nested if else condition here. I'll say if else sec equals 1, then give me say red, right? And if sec equals 2, so that's the last else condition, say let's give me black, right? So I've created an if else condition based on this, right? Let's see how it flows through. Okay, I think I've missed another bracket. Just give me a moment. This thing is getting out of the place. Okay, let's see where the brackets are missing. If else this closes, there's a bracket missing here. And if I execute this now, what happened? Error problem while computing. An error occurred in the first layer caused by error in if else. So there's a problem with if else. Let's have a look what the problem with if else is. So as you can see, coding at times can get a bit iterative, right? Because you have to basically get the code right every time or else it throws a problem, right? So what is it saying? If sec equals 0, error in if else, unused argument sec equals 0. Okay. So what's the problem here? You'd remember that whenever we are placing logical operators, we need a double equal, right? Right? So if I correct this here, then I would expect this to work. See? Yeah, now it would be working. Right? But it has given the entire if else. Yeah. So it is not considering that. So what we'll have to do basically is we'll have to create a new column in the data frame itself that gives you the color, right? Because R is, whenever you give R anything in the if else argument here, it's basically considering it to be a part of the color schema itself, right? So I would need to already convert it into colors and then only would it work. Does that make sense now?
Yep.
Yeah. So we'll have to remember that we'll have to by default convert it to the color we want, and only then would it work. Got it?
Okay.
Cool. So what do we know till now? You use the ggplot and geom functions together, right? The first argument here is the name of your data frame. Then you have an aesthetics argument where you are basically declaring all your relations between the data and the graph. Correct? Now, for example, x equals this, y equals this. Color is not necessary. ggplot is always used with geom underscore, which tells you what kind of graph you want to plot. For example, if I want to draw this kind of a scatter plot, I use point, right? If I were to use a bar graph, I would have done, say, geom, say, bar. Okay. Then I would have got a bar graph. Now, the problem is geom bar has a problem to draw here. Why is there a problem? Because this cannot draw a bar chart with these extensions of x and y. Right? Seems that they are saying that they really can't draw, say, with these extensions, a bar graph. But if you wanted to draw a bar chart, you can draw with geom bar. Similarly, you can draw a box plot with geom underscore box plot, right? You can do a histogram using geom under histogram, right? So all of these things are applicable, which can be used to draw different kinds of graphs. Okay. Similarly, geom point we have already used. We can draw something called a smoothened graph, right? So you can do geom underscore smooth, draw a smooth graph. Let's try this out here. Say, for example, I do a geom underscore smooth. Let's see what happens. Second, because it's a big one, it will take some time. But what you have got here is you have got separate smoothened line graphs for all the three factors. Yes or no?
Yes.
Yeah. So that's how you use a smoothened graphs. Does this make sense?
Yes.
Right? How you can use all of these? Okay. Now,
see, just wonder, right? Yeah. Will we cover multiple linear regression?
Not today. Today we'll be talking about mainly data analysis, like data visualization, right?
But later on we will cover it.
We'll get to that. Yeah, we'll get to it, right?
All right.
Now, one more thing here. For example, you can see a line graph here. If you want a point as well as smooth graph, right? Then what we can do? So geom underscore point plus this will help me draw points as well as smooth if I give a plus sign here as well. So I give a plus sign here as well. You will see all my points there. You'll also see my lines there as well. Okay?
Yeah.
Does that make sense? So what can we do? We have seen that we can draw multiple geoms together, right? Using a single data, right? With a single relationship between the data and this. What can we do? We can draw different graphs, right? Understood? What else? Can we change the size of these points, right? That is something important, right? So if I go to geom point, you will see there are some frequently used arguments here. Okay. For example, one of the frequently used arguments here is size and alpha. I don't think they have written these here, but size and alpha are the frequently used argument. Let's see what size and alpha together help us to do in these cases. Okay. So what size does is basically, as the name suggests, increases the size of your points here. Okay. So for example, if I sorry, I've misplaced my plots. Yeah. So if I go and say put size as equals to 2 here, you'll be able to see that my points have become larger, right? By default, you have a size of 1. Okay, so the initial ones were with a size 1.
What size works like LWD in the plot, right?
Yeah, the line width, but those were for lines. These are for points as well. Okay. Then you have something called the alpha argument as well. Okay, what alpha helps you do is basically adjust the transparency of these plotted objects. Okay, do you understand what transparency means?
No.
Right, opaque or transparent. Okay, so for example, let's see it with the help of a bigger point, right? So alpha equals 1 is the default one. You see there's no change, right? Alpha's value lies between 0 and 1. As I keep increasing, the transparency will keep going lower. So you can see that these objects will start becoming more and more transparent, right? Right? The color becomes lighter. Understood? So if you want your graph to have a color like schema where it's slightly less transparent, I can adjust this alpha argument. Okay? Does this make sense? Tell me. Yeah? Cool. Now, what else, right? There's something else that we can do here is, that is, if we go back to our, let's go back to a ggplot function, right? There is one argument here within your aesthetic function itself, right? We have an aesthetic function here, aesthetic argument here. Within this aesthetic argument, like we have color, we can also have something called fill. Okay, what can we have here? Comma fill. Okay, so I give fill is equals to factor of sec as well. Okay, let's see what happens now. What happened? Can you see anything recognizable here?
The line graph.
The line graph was already there, right? So if I say go back and back, sorry. Yeah, if I go back and this one, there's nothing recognizable that has happened, right? Yeah? Yeah. Now, what happens is, if you, by default, if you look at these curves, there are curves, right? Right? There are 3 curves that I have drawn for every section. You have the line graph as well as you have the curves, correct? Smoothened curves. It basically fill argument tells you the color of these curves. Okay? Does that make sense now? What does the fill argument tell you? But it didn't work for us. Why didn't it work for us? Again, we didn't put it in the AES argument. For it to work, we'll have to make sure it lies within the AES argument. Why? Tell me. Because again, it is a mapping between the data variables and a graph, right? That for different types of sections, I want different colors. Now, if you have a look, see our graph curves are also shaded with a particular color. Got it?
Yeah.
Yeah? Does that make sense now?
Yeah.
Yes or no? Tell me.
Yes.
So by default, you will have a lightish gray color. As you keep increasing the sign, it will change colors. Right?
Yeah.
Got it? Any questions so far? Tell me.
No question.
No? But one of the important things here is, what if I want my points to be different for these different sections, but I want to smoothen the graph that is not different for each of the categories, right? Right now, my points as well as smoothened graphs are different for the different categories, correct?
Yeah.
Yes. What if I want it to be the case only for my points and not my smoothened? Okay. So what has happened is, because I have given in the ggplot, right? They have used it for both my points and my smoothened graph as well. This color part of it. What if I delete it from here? For example, if I delete it from here, okay? Yeah, I've given the aesthetics argument only to define my x and y here, and then I'll use my aesthetic arguments just inside my geom plot. Okay, so in my AES, I'll use AES here, right? And here I'll say, right, color is equals to, again, say factor of what was the name? SEC, right? So now when I execute it, you'll see that I have just one smoothened graphs and the points are different for different colors. Earlier, there were 3 smoothened graphs, right? Because it took the distinction also for the smoothened graphs. Understood?
Understood.
Yeah. So your AES can also be the aesthetic argument, right? Can be used specifically for particular like geom points or geom smooths as well, based on what is it that you need.
Oh yeah.
Okay.
Just wonder, right? What is the smoothen graph used for, like day to day?
What is this?
The smoothen graph, like I think
the smoothen graph can be used for a lot of things, right? So it basically helps you for better data visualization, right? It helps you to get a boundary of things as well, right? That in most of the cases, your like data lies in this range, right? This is a trend line of your data, so as to say. Correct? Like if you do a linear regression, this is the trend line, the fitted line between
correct.
A and B, right? And this is basically interval of sorts, right? That most of the times your data will lie between this and this. That your basically, if you think about it, a sort of a confidence interval for your trend line.
Mm-hmm. But right? By default, is it still 95%?
Is it still, sorry?
Is the interval still in the 95% confident interval?
No, I don't think they've defined the confidence interval here. I'll have to look through the package, like what exactly this is. But there's a statistical method for smoothing here. It's not strictly like a 95% confidence interval. What they have is they have a smoothing method. Okay, so whenever you see a smoothing method, they are saying LOESS is the smoothing method. Yeah, so you have usually two smoothing methods. You have the GAM smoothing method. You have the Loess smoothing method. Now, the smoothing method is again beyond the scope of our exam as such, and usually not a lot of people use. But what you can think about it, it is a technique that helps you smoothen your graph. It tells you that most of the times your fitted line lies in this particular range. Okay.
Okay. Because in day-to-day basis, I really use this smoothen graph.
Right. So, see, on a daily basis, maybe you are not going to use this, right? But it's really going to help you to visualize your data better if you are presenting complex things. Yep. Okay. Cool. What else? So we've got basic ggplot. We've got how geom function works along with it. Multiple geom functions can work with it as well. You can give the aesthetic argument within the geom function or within the ggplot function, right? So that is our basic thing, right? What else? Yep. Now, there is one more argument in our geom smooth function. Okay. For example, if I use the geom smooth function here as it is and put SE is equals to false here. Okay. SE is equals to false. What do you see? I have just got the regression line. I have not got the smoothing effect. Yes or no?
Yes.
Yeah. So that is what this helps in.
What is SE?
So SE basically stands for here is your smoothing option, right? So it is putting your standard error of smoothing, right? That is basically now set to what? False, right? So it is not giving you the standard error of the smoothened graph. It is just giving you one smoothened line. Right?
But then what's the purpose of SE equal to? I mean, if we don't want the smoothened graph, then why don't we just remove?
Yeah. If I just say do geom equals point and have a look at the graph, we'll just get the point graph.
Okay,
right?
Okay. Yeah.
This also helps you give a fitted line.
All
right?
right.
But I don't want that standard error plotting, right?
Yeah.
If I remove this SE false, remember there was one more grayish area that you got. I don't want that. That is where I use SE equals false.
Understand.
Okay? Those bands have disappeared. Correct?
Yep.
Yeah? So far, so good?
Yes.
Any questions still here? Tell me.
No.
Yeah? Cool. Now, what can we look at more? Let's just think about it. For example, we have looked at almost like, so this was basically your basic of ggplot function. Okay. This is your basic use of ggplot function that you can use ggplot, you can use geom point, you can use geom smooth. Now what else, right? Now there's something called facet wrapping, okay, or something called usually just called faceting in R, which basically helps you divide your graphs into different groups. Okay. Yeah, you can use a particular category in your data to divide your graphs into different groups as well. Okay, let's try to understand with this example itself. For example, I add one more plus here. Okay. I write plus facet. You have this thing called facet wrap. Okay. And I use like I'll basically have to tell what variable is I'll use on the basis of which faceting needs to be performed. Okay.
Yep.
So for example, I need it to be performed on this section variable, right?
Yep.
I needed a different graph for 0, I need a different graph for 1, I need a different graph for 2. Okay. So what I'll do here is I'll basically write swiggle, this symbol we know from linear models, right? Swiggle of SEC. Okay. And the moment I plot it, you'll see 3 different graphs have been plotted for all of the 3 different types of sections. Okay, for 0, I've got a different one. For 1, I've got a different one. For 2, I've got a different one. So for first, you give the name of the variable, right? And then you give basically like the variable, and then draws a graph for you.
Yeah,
understood?
Basically, we want to split into the 3 different graphs based on the SEC, right?
Based on this. Exactly. Now you may want to have 2-dimensional thing as well, right? For example, you might want, say, there was a different variable, second section, right? And that was ABC, right? And you want on the basis of that. For example, you could have a combination of A0, A1, A2, B0, B1, B2, C0, C1, C2, and you wanted a different for each of them. Then you could have used facet wrap something, swiggle something. For example, let's look at it with the help of an example. I had, say, sec2 here as well, which was based on just A's and B's. Okay, let's just take A, comma B here. Okay, and let's have 100 of these and replace is equals to, sorry, just a second, 100 of these and replace is equals to true. I've got my frame. If I just did a ggplot of this, I'll get what I had till now, right? But if I use sec2 as well, you'll see a 2-dimensional thing going now. A0, A1, A2, B0, B1, B2. Okay. So all the combinations of A0, A1, A2 have been used. Okay.
All right.
Got it?
Yeah.
Any questions here? Right. So this basically is called what? This is called faceting.
Yeah. So basically for the sec2, right, we generate 100 random number, then we divide them 50 for category A and 50 for category B.
Not necessarily 50, right? So the sample function is basically just randomly putting A in some places, B in some places.
All right.
Okay. Yeah. What else? Right? This has basically helped you do what? This has basically helped you do remember the par MF row functionality we had? Right? Par MF row, we did a 2,2, helped us divide in a 2x2 grid or a 3x2 grid. This automatically does that thing for you. You can see how powerful this is basically. Yes? Right? What else? Right? You also need to plot, after plotting your graphs, you need to label your graphs, right? You need to put titles, subtitles, captions, right? So you can have additional functions that can help you do that as well. Label your x-axis, like the xlab, ylab, xlim, ylib within the plot functions. We can also use all of that here as well. Okay, we'll learn how we can do that. Okay, we'll come to that. But before going into that, remember this one thing from a PA exam point of view. A lot of the times in the past, what has come in the exam is they'll, for example, give you this graph and tell you what is missing in this graph, right? So the key thing that is missing, for example, is your labels, right? Your x-axis doesn't have a reasonable label. Y-axis does not have a reasonable. There's not a title to the graph, right? So those are the key problems with the graph, so as to say. Yeah? Yes or no? Right? So for that, we have additional function, right? So I'll do another plus. I'll put, say, labs. Okay? And then within here, I'll give, say, the title. Say the title here is simulated X and Y. Simulated, say, measure 1, whatever that measure 1 in my question is, and say measure 2. Okay? So now you will see I'll have a title to the graph as well. Yeah? What else can I do? I can provide X lab and Y lab, right? So xlab, because I'm already within the lab function, I don't need to write xlab by lab. I can simply write x. Right? For example, this was measure 1, variable 1. Right? I can put y equals say measure 2. Right? So if I execute now, you will see instead of a and b, I'll have reasonable writings there as well. Okay. Yeah. What else? You might want to reduce or increase your coordinates. Correct. For example, your coordinates are too high, too low. Right. You don't want the coordinates to be in that way. Right. This way we used xlim and ylim. Right. For that, you have a different function. For example, the function that we use here is coordinate Cartesian. Okay. Within the coordinate Cartesian, you can put xlim equals what to what. For example, xlim here is from 0 to 100, right? Say you want to show 0 to 120 just to make sure there's nothing beyond that point, right? So you do that and see you have gone up till 125. Okay. Similarly, you can show, say, ylim is equals to starting from 0 going up till 850 for the time, right? And see, it goes up till, I started from 0. I think that's too low. What happened? Just a second. That started from somewhere, say 380, right? And let's process this now. Looks better. Yeah. Does that make sense? Yeah. So you can basically, what I'm trying to say is you can adjust your x limits and y limits using this coordinate Cartesian function. So we have learned a few more functions. We have labs, we have coordinate Cartesian. We also talked about facet traps and facet grids. Okay. So far, so good. Any questions till now? Tell me.
No.
Yeah. All good.
Yeah.
Yeah. Cool. What I want you to do is, I know this is a lot of information to digest for the timing because there are a whole lot of functions, right? You have GGPlot, you have geom, you have labs, you have facet traps, you have coordinate Cartesians, right? There are a lot of functions at the end of the day. So you need to be basically able to retain all of this information as well. So at any point of time, if you think it's getting too much for a single class, just let me know. Okay? Yeah? Good. Perfect. So let's get to the next point. We also need to talk about, say, histograms, box plots, all of those things as well, right? So we'll try to. Do you want me to cover it right now? We can spend 10 minutes to cover it right now, or if you think it's getting too much, we can take it for tomorrow as well. Anything?
Yeah, I think it's okay to continue for another 10 minutes.
Okay, cool. Perfect. So let's talk about, say, histograms. Yeah. What are histograms? I think we discussed about histograms last class, if I'm not wrong, right? Yes. Yeah. Cool. So histograms is basically you have your vertical buildings, but they are joined to each other. So area under graphs matter. Exactly. Right. So let's try to understand how would I say draw a histogram here. Right. Remember, for histogram we needed just one argument. We didn't need two arguments. Right. We didn't need x and y both. Right. So if I try to give ggplot x equals this, y equals this, it will maybe throw something that's not logical, right? So for ggplot, for example, I give df1, comma, I'm drawing using aesthetic because I'm connecting my variable x to variable a, right? So I'm drawing connecting my data and the graph, and then I'll use what? I'll use geom underscore histogram. Okay. Now, if I simply do this, you will see something that's not very visually pleasing, right? So we'll have to make this visually pleasing as well. Correct?
Yeah.
Yeah. How do we do this, right? So the first thing is we can provide it some fill, right? Some color for it, right? So for that you have the fill argument here. For example, I give fill equals blue. It will give it a blue color, right? Yeah. I want to control the number of bars that get drawn at 2 times as well. For example, I want only 20. I can see here a large number of bars. So say let's limit it at say 15. Okay. Now the number of bars have come down to 15. Okay. So this bins argument here will basically tell you how many bars do you want in your histogram.
Yeah.
Okay. So this is your key argument here, which is
just wonder how about if I want to add a border in between so that I can see exactly the bar in like each bar.
Yeah. So we'll come to that. Don't worry. I'll come to that. But is this point clear?
Yeah. Very clear.
Cool. So you have used geom of histogram, and then you want to be able to like show it in terms of like the lines as well, right? The lines between the graphs, so that it helps you to be able to distinguish between the two.
Yes.
Right. Let's see. Okay. Let's talk about that as well. Whether there's an easy way of doing that, because the concept of like histograms is not to provide that, but let's just see if we have something in the help text that helps us to do that. Say geom underscore histogram, right? So geom underscore histogram has this basically thing, right? So the main thing here is your bins, right? It basically tells you how many bins you want, right? Let's just see if there is something else that helps us increase. So you do have something called bins width. It can help you to change the width of the bins, right? The width of the bins in the sense the how thick would the bins be. Yeah,
basically it works like bricks, right?
Exactly. And then you have this boundary, right? So I think this boundary or the center will help you to like give the boundary between the two winds, right? So let's try this out. Say if I use say boundary is equals to 0.5, right? Boundary is equals to 0.5. Let's see what happens. No, I don't get a boundary here. Let's read this through. Yeah. The boundary specifies the boundary between. Note if either is above or below the range of the data, the things will be shifted by appropriate. So to center on integers using. Okay, this is something else. So this is not your boundary of your bins. This basically specifies the start boundary and the end boundary. Okay, it's not a boundary between the two bins. Okay, I think one of the indicating whether the left or the right is included in the bin. No, so geom under histogram won't help you to draw something that has a light between the two, right? You can't draw a line between the two. So we'll have bar charts for that. But for continuous data, where you don't want like it to be continuous, it won't help you to get lines. At least I can't see anything here that can help you do that. Okay. Yep.
Yeah.
Just one more thing. Let's try here. Say put closed equals right.
So how then if we want to see I mean, this is a bit not clear, right? I mean, if
right.
The first
I get
two
bars, Yeah. So I totally get your point that this is not as clear. So that's where we'll have to maybe resort to something else, right? Like we'll try to get to some other functions that help us to like get those lines, right? So we'll try to see what other options we have.
I mean, it's okay if you want to, I mean, search on the internet first, or I mean, it doesn't have to. I mean, you doesn't have
right
to.
Now. I'll maybe check for it.
Yeah. I mean, we can discuss in the next class.
Yes. We'll do that. Yeah. Now, there's one more thing that I want to introduce before closing the class for today, and that is for like storing GGplots as well. Okay. So what we can basically do is we can store all these GGplots, right? So for example, I can do P1 is equals to this. Okay. And nothing gets plotted right now. It is just storing into variables. Okay. So I can do P2 equals this as well. I can do P3 is equals to this as well. I can stop here. Okay. And then what happens is if you look at the environment right now, we'll have P1, P2, and P3 as 3 graphs. Okay. So R has recognized that you have 3 graphs with yourself. Okay. Now what you can do is you can use a function that helps you get these 3 graphs in a single manner on a line. For example, what I can do is I can use a function called the grid.arrange function. Okay, what is the name of function? The grid.arrange function. Okay, Then I'll give say P1, comma P2, comma P3, right? And the number of columns I need is 3. Could not find grid.arrange. What happened? Oh, I think grid.arrange is in your grid extra package. That's why. Just give me a second. Let's get this grid extra graphics first. And there's one more function that we'll need for this called the grid extra. Okay. Let's install these two. Make sure that these two packages are installed. Just give me a second. Takes time to install this.
Just wonder, right? See that. So our goal is at the end of the day is we want to learn until the machine learning, right?
Machine learning as well. Yeah, machine learning is one of the things as well. So what happens is, why are we going like this deep into graphs? The main reason being, a lot of the times for your machine learning knowledge to work, you should be able to visually analyze your graph and then decide what is the best form of machine learning that you can, like machine learning model that you can take. Okay. So
I see. Okay. So it's based on the graph.
Right. So not just based on the graph. Like there are statistics as well. For example, you look at mean, median, mode, and confidence intervals, all of those things. You look at, say, a linear model as well. But the point is, machine learning is all built on the knowledge of basic statistics and like analysis, right? If at times you have to make, before actually, like you can learn all the machine learning models in the world, right? But to decide what is the machine learning model that should be implemented in this case, you need to have some good idea about what the data is, right? How the data is behaving and all of that things, right? And that is what these things will give you the these graphical things will help you with.
So is it tested also in PA exam? Just wonder.
So yeah, it's tested very well in the PA exam. So you have a complete chapter on GGPlots. Okay.
Okay.
Yeah. So in PA exams, what they usually do is they give you a very big, large raw data set. Okay. They'll ask you to perform analysis on that data set, and that might be any graphical analysis. And then they'll ask you to maybe build linear models on this, perform machine learning on it. It will be like incremental in nature. It won't just be build a machine learning model out, right? It will be like step by step.
I see.
Okay. So today what we are basically learning is your GGPlots, right? One of the other like packages that help you with data summarization and data exploration is tidyverse as well. Okay. So we'll learn a bit about tidyverse and more about GGPlot the next class as well.
All right.
Okay. So like, I think I'll put something either to tomorrow or day after. In these two classes, what we'll try to do is completely understand all the data visualizing sort of functions that SOA wants us to understand for PA exams. Okay. That's why I wanted you to be strong with, say, plot, function, all those functions, because if you didn't understand those, GGPlot would have become too difficult for you. Right? If you have directly looked at GGPlot, so what SOA does is they directly jump into GGPlot, facet traps, geom histograms, geom points, right? When I usually take classes, what I suggest is first go through plot, histogram, bar plot, so you understand what those graphs are, and then you use GGPlot to your advantage to be better able to plot these things. Yeah? Makes sense? Cool. Perfect. So that is we looked at what grid.arrange, right? So you can use grid.arrange to be basically able to have multiple graphs on the same window like this after storing it in multiple variables. For example, if I had P4 as well, I could have put nqual equals to, R would have automatically recognized you had 4 graphs, number of columns are 2, would have drawn a 2 into 2 graph, right? I didn't have P4 here, so if I did a P4, I would have gotten a 2 by 2 grid. Yeah. Got it? So that is what we have here before we start with tidyverse. I wanted to discuss before we close the class for today, what is a good time tomorrow for you?
Anything, I guess. I think maybe I think tomorrow I have appointment between 10 a.m. 10 a.m. means like 8:30, right?
Okay.
8:30 Indian time to 9:30 Indian time. Yeah, right. I think so. Just that time I'm not available. The rest I'm available.
Can we have something 6:30 p.m. my time? That's 8 p.m. your time.
Sure.
Yeah. Cool.
Yeah.
Then I'll schedule something for 6:30 p.m. and then let's see. Take this ahead tomorrow. Okay.
So in the next class we will discuss about the tidy first and then the GGPlot as well.
Correct.
Then after that we will discuss about the multiple linear regression.
Not soon after that. First, I'll make some practice questions on some plotting, and then we'll get to that, because I don't want to just get done with topics for the sake of getting done with topics, right? We'll practice some questions on this, and then we'll go to linear models.
Okay.
I'll right now we are just understanding
because the video that you suggested me to watch is about the multiple linear regression. So
So like all those are founding blocks, right? Like we did plotting, right? What we are doing right now is built on that, but is not exactly that, right? The same thing would be with linear models as well.
I see.
Okay. Cool.
So how just wonder how many % have we covered for? I mean, out of the entire material.
For the PA material, so if you think about it, PA is split into 6 course chapters. Okay, one of them, they start with basics. They go to the second one is data exploration. The third one is linear models. Okay, so we have completely done basics, right? By tomorrow we should be get done with the second module as well. The third module is about linear models. So you can assume we have done, say, 35 to 40% of linear models, right? And by the next week, we'll be done with, say, 50% of it. The entirety of linear models as well. So we'll be done with, say, 50% of the PA syllabus.
I see. Okay. Understand. Yeah. I think it's. I think thanks for teaching classes.
No way.
Very clear. I mean, just that. I mean, like what I request regarding the recorded video is, I mean, please upload the English version, because so far it's still in Hindi. So I really lost the explanation.
So if at any point in time you feel that you don't need to watch it any longer, you just ping me. We'll schedule a class as soon as possible. Yeah.
Okay. Actually, I can follow the function, because the function I can go on Google. No. Sometimes you interpret, right? Like what is this? Like you interpret the data, then that part I cannot get.
There's no point of doing that. So don't worry about that. Just ping it in the group like you did today, and we'll schedule a class as soon as possible. Yeah.
Okay.
All right. Cool.
Thank you, Siddharth.
Perfect. Thank you.
Yeah. Bye. See you.